Hi, this is Ben Osborne with Thermo Fisher Scientific. In this video, I'm going to show you how to set up a very simple data-independent acquisition experiment with a Q-exactive running QE software 2.2 SP1 or later. And in these newer softwares, you have this new option here for data-independent acquisition, and we simply pull it over and add it to our running screen. Now, in the DIA experiment, your inclusion list now becomes the mass ranges for your DIA. So we have a completely new function for this here, and we can go in and fill in our mass ranges that we want to do the DIA on, or we can simply make a list in Excel. In this case, I'm running from 400 to 900 m/z, and I can simply copy this and paste it into my inclusion list. Put all 21 lines in there. Now, something to keep in consideration while setting up a DIA experiment is cycle time. And if we look at this here, if we're going to run the DIA experiment at 17,500 resolution, we're talking about 64 milliseconds per scan. If you sum that up, we're looking at getting through this mass range of 400 to 900, running about 1.3 seconds. So it's something to keep in mind. Your peak width and the number of ranges you want to look at, because you don't want to run over your peak. If you're using a very narrow UPLC type peak, you don't want to look from the range from say 300 to 2000 and possibly only get one scan across each peak. So that's something you really need to keep in consideration with any kind of DIA experiment. But here, for this, I'm thinking this is going to be a triptych digest. 400 to 900 is going to give me a very good coverage of this range. So now I've got that up, simply accept my inclusion list, and I'll just set up my experiment. Here we'll just say experimentally we're talking 60 minutes, so then we'll stretch out gradient so it's here. The DIA, in this case, in order to stick to my 1.3 seconds, I am going to do this at 17,500 resolution. And the AGC target is going to be very dependent on your mass range. In a presentation that Dr. Makarov gave a couple years ago, I said that we started to see space charging with a m/z range of 2, about 2e4 to 5e4. So in this case, I plan to run an isolation width of 25. And so I'm thinking that would be about 10 times as much. So I think I can get away from anywhere for a target from 2e5 to 5e5. In this case, I'm going to err a little higher and say 5e5 because I am looking at a 25 Dalton window instead of a little more than 10 times where we saw that space charging. Here you have the options of setting your injection time to whatever you want, or you can just set it as auto. In this case, it will just match your fill time to the transient time of the orbitrap. So in this case, it will be doing 64 milliseconds at 17.5 resolution. In this case, we're going to leave the loop count and MSX count to 1 because we'll just be cycling back into the DIA because that's all we're doing in this very simple experiment. More complex experiments can be done by using multiplexing and breaking the windows into subsequently small windows to get not only a more complex experiment but better data, but we'll not go into that here. Simply, we're going to do the experiment in 25 Dalton windows, and we'll set the first max in the low range. I don't think that very much usefulness is going to come out of the extreme low end in this type of experiment, and then normalized collision energy would be what is appropriate for your Q-exactive. Now, an additional feature of DIA on a Q-exactive is that we can go ahead and throw in a full MS scan, and if we do this, in this case, we would want to take the DIA and we would want to give it a loop count. In this case, we're doing 20 scans. That way, we'll do the 20 DIA windows, and we also still get a full MS1 scan in there for possible confirmation if this is data that would be valuable to your processing scheme. But again, this was just a general setup on how to get a very simple DIA experiment going. And as always, if you have further questions, I strongly suggest that you check out Planet Orbitrap for new materials and methods. And if you have specific questions, you take a look for those questions on the ThermoBrims portal, or if you don't see it, you can post your own. Thank you very much.